And here's an equation. We're going to graph it. We're going to label the vertex and the axis of symmetry. So I cannot just start performing transformations on this equation. Why not? Why can't I say, oh, there's a stretch of this, the vertex is here and here. Why does that not work for this example, but it worked in our homework last night? Brandon? Good, it's not in vertex form. So there's still some transformations here that we'll generally see, and you'll catch on to that. But if it's not in vertex form, if I want to use transformations, I either have to rewrite it into vertex form, or I just have to have another way of graphing it besides that, okay? So we went through kind of a little PowerPoint overview to get your brains back working in this area from when you left Algebra 1, okay? And we talked about when we're graphing stuff like this that sometimes the solutions are nice to have but might not be necessary. So I'm going to graph this. Do I necessarily have to include the solutions here if my goal is to graph and have the vertex and axis of symmetry? No, okay? Do I need the vertex point to graph my parabola accurately? Yes, okay? So I definitely need that piece of information, and with that would come the axis of symmetry. The other points, it's going to be up to my discretion whether it's easiest, because solutions are really easy to get, to use solutions, or to just use other points on the graph, because that's easier, okay? So anybody remember how we could get the axis of symmetry or part of our vertex when the equation is in this standard form? So a reminder that the standard form is this guy. So when we have things in these spots where it's not like A, H, and K, but we have an A, a B, and a C, what kind of things that help us with quadratics use the A, B, and C? Like quadratic formula is one, but that finds solutions. Casey? Over 2A. Good. So quadratic formula would find us solutions, right, by plugging in A's, B's, and C's. But then this smaller formula that we saw is the average of the quadratic formula. It finds us the middle in between the solutions, which means it's finding us our axis of symmetry. Okay? So since this is already written in the format where they are giving me A, B, and C, to me, this seems like the easiest starting point because I can just plug in the numbers from my equation since it's written in that format. Okay? So my B is negative 16, so I'm going to do the opposite of negative 16 and divide that by 2 times A. So I'm going to have 16 over 8, which is 2. Okay? So right now, I know that my axis of symmetry is 2. Oops. I'm not just going to write 2. X equals 2. Jonathan? But it doesn't have, this exponent is only on X. If they wanted it on 4, there would be parentheses around the 4 and the X with the square. So I know that my axis of symmetry is 2. What else do I know? That the X coordinate on my vertex is 2, right? So far for my vertex then, I know that it's at 2 comma something, okay? So I know everything on my graph is kind of set in this area. Here's my axis of symmetry at X equals 2. How am I going to get the exact position of my vertex? Brandon? Good. Plug 2 in, okay? So remember how the vertex kept coming up, and if it wasn't H and K immediately, it was like once you got the X value, do F of that to get the Y value, right? Plug it in. So I just need to plug it in to here. So I have a little arithmetic to do. Okay, I'm going to get the Y value by doing 4 times 2 squared minus 16 times 2 plus 10. So exponents first. Then multiplication or division from left to right. Then addition and subtraction from left to right. So I get negative 6. So 2, negative 6. So now you could go ahead and solve it using like quadratic formula or try to factor it or different things like this to find the solutions to get 2 other points to graph. Sometimes that's really not a good idea. 1, it's a lot of time. And 2, if it's not factorable, the solutions might be things like rad 2 or something like that. Or if it faced downward, we wouldn't even have solutions, right? We wouldn't have x-intercepts. Okay? Now I know that this one faces upward because the A value is positive. So I know that it's going to have some, but I don't know if that's the best way to go to get some other points. So how else could I get some other points if I'm not interested in necessarily finding solutions? Jonathan? Good. Plug something else in for X. Okay? So we're going to plug anything else we want in for X, but given that we know this is a quadratic and it grows very fast, right? And that it's being multiplied by 4 right here, which is just going to make it grow even faster. Do I want to go plug in like 10? Probably not, just because of like logistical reasons. I'll get a number, but it's probably like really high up on my graph. So I want to stay pretty close to the vertex and not go too far away, because the quadratic grows so fast that once I go further away, I'm going to get really large numbers. Okay? So maybe something like 1, maybe something like 3, because it's on the other side. Or in this case, I can kind of do two things at once. I can find the Y-intercept by plugging in 0, which is also not very far from the vertex. And so that would be a good idea. So I'm going to choose 0. And I'm going to find the Y coordinate that goes with this. I very much enjoy plugging 0 into standard form, because what happens when you plug it in? This just becomes 0, this just becomes 0, and we just get 10. So standard form does have some handy things about it too, right? So if you didn't understand what we just said, we basically said, because of all these zeros, we just have 0 minus 0 plus 10, or 10. So I have the point 0, 10. So I'm going to plot that. Wasn't sure if my graph was 10 by 10. Okay. And so I have this very skinny looking parabola. Notice I kind of automatically made the mirror image of the point at 0, 10 on the other side, because I know how a quadratic behaves. And then you have to decide if this makes sense to you. So little hint here, the A value here is like the A value normally. The other things are not like H and K. But the A would be like the A if you factored it out of everything and then worked on that stuff to make it fit vertex form. So does it make sense that if I had an A value of 4, my quadratic would be so skinny like this? Okay? If it's taking the normal thing and kind of like stretching it by a factor of 4. Okay? That's why my points were so far apart. All right, so we have vertex, we have axis of symmetry, we got our graph. We're good. Jonathan? Yeah, you can plug that one in too. I just used this and drew it, and my drawing is very bad, as you can see right there. Brandon? You wouldn't see that number. No. And as a matter of fact, when we write it in vertex form just has an A, H, and K technically, but because we're going to study other functions later, we study them with horizontal stretches and compressions here. But all of these, you can write them with only an A value and not that. So when we get a little bit further on in the process, we would factor this 4 out completely, and then we would leave something where we would work on completing the square. And completing the square would make this turn into a perfect square, but we probably had to add something extra in there. And so you can see how it would look a lot like A, H would show up in here, and K would show up out there. Okay? Any other questions? Thank you. No? Okay, so let's see how the calculator, we changed sheets. Sorry, Marcus. Let's see how the calculator can graph these, how we can get a good viewing window, and specifically our focus on the calculator, because we're looking to do something new now, is how the calculator finds minimums and maximums, or how the calculator finds X-intercepts. So that's not something we did before. We did do data, we did do graphs, we did look at windows. We did not look at functions such as finding X-intercepts or finding minimums or maximums. Okay? All right, so if you need to borrow a calculator, there's some in the back. Again, if you have one, take it out. We're limited by the number we have in the back, so if there's not enough, we just need to make sure everyone has one side by side. Okay, so turn on the calculator. Go to the Y equals menu. and clear out whatever's there. So any form or equations that we don't want. If any of the plots are turned on, we're not working with data right now, so please turn them off. That means scroll up to where they are bold, press enter on top of them, and then scroll back down, and they should not be bold anymore. Okay? All right, now we're going to go ahead and we're going to type in this equation from your note guide. So it's y equals negative x squared plus 6x plus 3. So on your calculator, in the first y equals, remember to use the negative button first and not the minus. So negative, your x is here. For squared, they have a squared button. For higher powers, we can just use that little caret thing above the division sign and type whatever power we want. So squared plus 6x plus 3. Now, before I press graph, this calculator may have been used for many things, including viewing data last, so it might have some crazy window. I'm going to go ahead and zoom back to my standard 10 by 10 window and then adjust it if like my vertex and stuff isn't easy to see in that window, okay? So remember, zoom is right here in the center, zoom, and we're going to choose choice 6, which is standard. So here's what that looks like. It's okay, it's not bad. I can see the parabola, but if I'm trying to find the vertex, small problem here, right? But this is where some knowledge of something you still need even when using the calculator. You have to understand it faces downward and the vertex is up at the top, which means we need to extend our viewing window up more towards the top. So I'm going to go to my window, and I'm going to change my y maximum to be something higher than 10. So maybe I choose 20. And then press graph again and see if that's a big enough adjustment. There we go. Okay? So now I have my parabola. Now, what I want to do is I want to be able to actually find x-intercepts and the vertex. So your calculator can do calculations from the graph. It's up here in the calculate key that's with the graphing key. So we're going to go second and press trace, which is really this calculate menu. Here's all the different things that it can calculate. So let's say we want to calculate our vertex point right now. Which category do you think that falls into? Intercept. Not intersect, because that's going to be like two different things intersecting each other. So the vertex of this parabola would be what, right? Good. It's going to be the maximum. So we're going to choose choice 4, maximum. Now, if our parabola faced the other way, we would have to choose minimum, okay? So we're going to choose choice 4, maximum. Now, notice the calculator's instructions. It says left bound, question mark. It wants you to determine for it a point that is to the left of the maximum. So use your left and right arrow to scroll along your graph. It doesn't really matter. I could push it where I was right now for the left bound. But maybe I go up towards the vertex, but don't go where you think the vertex is, and just press enter at some point to the left of the vertex. Okay? When I press enter, notice that the question at the bottom of the screen changes. It now says right bound. It now means please give me a point that is to the right of the maximum. Okay? So scroll so that you're to the right of the maximum. Press enter somewhere over there. Then it says guess, just kind of go where you think it is. Press enter. Your calculator then does some calculus and determines that this is where your vertex is. Now, it does calculus, so there are some imperfections, okay? I know the vertex has 3 as an x-coordinate because negative b over 2a would give me 3. Mine says 2.99999999995. We can round that to 3. Because there's so many 9s after the 2. If it was like 2.918874, I wouldn't do that. But given that it's like 2.999999999, we'll say 3, okay? So our vertex is at the point 312, okay? All right, now for our x-intercepts. I'm just writing this down so when we go back to the note guide, we can fill in the proper information. So let's go back to the calculate menu, and let's say if we weren't looking for the maximum or the vertex point, what on the calculate menu do you think finds our x-intercepts for us? So intersects means you've drawn two things and you want to know the point they intersect at. But what word up there means the same thing as x-intercept? 0. So choice 2 is the choice that's going to find our x-intercepts for us. Now, you need to do this 2 separate times because there are 2 different x-intercepts. So first of all, focus. Which one are you trying to find? So just for myself, I'm going to scroll to one before I answer any of the calculator's questions. I am trying to find this one, okay? So the first question is left bound. Where is something to the left? Scroll a few spaces to the left, okay? There is a point to the left of the 0. Then it asks right bound. Go back to your 0, scroll a couple times to the right, press enter. Then it says guess. Go back out where your 0 is, press enter. There you go. This 0, the y value is 0 and the x coordinate is negative 0.4641016. That's one of them. The other one needs to be found separately. So you would go back through that process again at the other 0, okay? So I'd go back to calculate. I would pick 0 again because I'm trying to still find a 0, but not this one over here. Instead, this one way over here. Yes, back to the calculate menu, tell it 0 again. And this time, all I did so far, I didn't answer any of the calculator's questions. I just took myself in the area I want to be so I don't lose track of what I'm trying to find. And then it says left bound. So I scroll a couple of times to the left of that, press enter. Back to it, it says right bound. Go a little to the right, press enter. Guess. Go somewhere by it, press enter. And it tells me the other x value when y is equal to 0. Okay? All right, so your calculator can graph for you and can tell you all of these things. All right, so when we're dealing with data and stuff, we're going to do that. But we are still going to test you that you can do it all by hand, whether it's in standard form, Vertex form, any form, because you have to know enough to size your window and know that this information makes sense with what you're doing. Okay? So if we go back to our note guide, we'll fill this information in. So our axis of symmetry, based on the fact, I guess, that our vertex was at 312, okay, and our x-intercepts were at negative 0.464, 0, and positive 6.464, 0, then our axis of symmetry would be at x equals 3. Our graph had a maximum value. Okay? We had to know that to tell the calculator to do the right thing, and it was at 12. The domain was all real numbers, or negative infinity to infinity. And the range, since it was a maximum at 12, means everything was below 12. So y was less than or equal to 12, or in other words, from negative infinity until 12. Okay? And then any notes that you want to take for yourself about the calculator.